Okay, so now let's look at question 6, right? What is the expected return of a stock that's a beta of 1 if the expected return on the market is 15%? So this should be pretty straightforward. So if the expected return for a stock is a beta of 1, if the expected return on the market is 15, it's going to be 15%, right? Because why is this the case? Okay, because what happens is that it has the expected return is exactly the same as the market return when it's a beta of 1.0. Now, if the beta was 1.5, then it would be 1.5 times 15. If the beta was 2, there'll be the expected return will be 30% because 2 times 15. So that's pretty much it. Okay, now let's look at 7, right? Koskin stock has a beta of 1.2 and Quinn has stock beta of 0.6. Which of the following statements is most accurate? Now, if you look at Koskin and Quinn, we can tell straight away that Koskin has higher systematic risk than Quinn. So Quinn has lower systematic risk. Okay, so the betas don't really tell us anything about total risk. They also don't tell us anything about idiosyncratic risk. They only tell us about systematic risk. Okay, so therefore, when we look at these three statements, the expected rate of return will be higher for the stock of Koskin than that of Quinn. So we can say that that is true because Koskin has a much higher beta. Okay, if we look at part B, stock of Koskin has more total risk than Quinn. We can't say that, we don't know because we're not giving any information about the idiosyncratic or non-systematic risk of Koskin versus Quinn. Okay, when it says the stock of Quinn has more systematic risk than of Koskin, that's completely false because Quinn has a beta of 0.6, whereas Koskin has a beta of 1.2, which means it has higher systematic risk. Okay, so now we're going to do question 10, right? Chapter 7, question 10. The market price of a security is $40. All right, I'm going to write that down. Market price of a security is $40. Okay, sorry. Right, so I'm going to zoom in a little bit more, make that easier to see. It's $40. Okay, expected rate of return is 13%. Okay, the risk-free rate is going to be 7%, and the MRP is going to be 8%. Okay, so percentage 8. All right, what will the market price be of the security if its beta doubles and all other variables remain unchanged? Assume that the stock is expected to pay a constant dividend in perpetuity. Okay, now if the beta of the security doubles, then we know that the risk premium doubles as well. Okay, so the risk premium right now, it's going to be 13 minus 7%. What does that give us? Okay, that actually gives us the risk premium of the stock, right? Because basically the expected rate of return is 13% and risk rate 7%, the market risk premium is 8. Okay, so what we actually got to work out now, okay, is that the new risk premium is actually really going to be 12%, right? Because basically what happens is that we said that the beta doubles. So therefore, risk premium doubles. Okay, so it becomes new risk premium 2 times beta. Okay, so basically what happens is that this becomes multiplied by 2. Okay, so that means the new discount rate of the security is going to be 12% plus 7, right? Okay, so remember, the underlying formula over here is always the cap M equals to RF plus beta times RM minus RF. Okay, so basically the discount rate is going to be the new risk premium of 12% plus the risk-free rate, which is 19%. Okay, now it says over here as well, okay, that the beta doubles and the stock pays a constant dividend in perpetuity. Okay, so if the stock pays a dividend in perpetuity, okay, that means we know that price equals to dividend divided by discount rate. Okay, this is because ultimately it's that the dividend is a cash flow. All right, and perpetuity means that we have that formula where it's the PV equals to FV, right, divided by 1 plus R. Okay, and usually this is power of n, right? So what happens that because this is really in perpetuity, so basically we have just the dividend over the discount rate. Okay, so basically what happens over here, that means we have 40 equals to D divided by 0.13. So if you want to solve for the dividend, which is in perpetuity, D equals to 40 times 0.13. So that means that the dividend is going to be 5.2, right? Because it equals 40 times 0.13, okay, which is 520. So basically, in this manner, all right, we actually worked out the price of a stock, okay, if the beta doubles by using the cap M, and this is really the PV equals to FV over R. Okay, that's the formula for the present value of a cash flow into perpetuity. All right, so now let's look at question 12. Okay, so consider the following table which gives a security analyst expected return on two stocks for two particular market returns. Okay, so we have this table where you have market return, you have aggressive stock, let's call it A stock or aggro stock, call it defense stock. And then we have percentages here. This is going to be 3.5, this is 2, this is 5%, this is 20, this is 32, this is 14, okay? So what we need to work out now are like what are the betas of the two stocks, okay? So what actually happens is that the beta is the sensitivity of stock's return to the market return, or the change in the stock return per unit change in the market return, right? So what happens is that we can call the aggro stock A, and we can call the defense stock D, right? So we have this information over here, and this is going to be M, right? So we can actually calculate each stocks. We can actually basically compare each stock's beta by calculating the difference in return across the two scenarios divided by the difference in the market return. Okay, because ultimately what happens is that we're actually looking at remember we said that the beta, okay, is actually the gradient of the line, right? So beta A equals to 2 minus 32 divided by 5 minus 20, okay? So this gives us equals to 2 minus 32 divided by 5 minus 20, which gives us 2. So beta A has a beta of 2, right? So if we look at the same thing for stock number B, it's just going to be beta D equals to 3.5 minus 14 divided by 5 minus 20. Okay, so that's going to be equals 3.5 minus 14 divided by 5 minus 20, which is 0.7. Okay, which makes sense, right? A defensive stock should have a lower beta, an aggressive stock should have a higher beta. So how do we calculate over here? It's because we actually understand that we can obtain each stock's beta by calculating the difference in its return across two scenarios divided by differences in market return. Okay, so now when we look at part B, what is the expected return of each stock if the market is equally likely to be 5 or 20%? So what we're talking about, this is just scenario projection, right? Okay, so basically we know that the expected rate is an average of two possible outcomes. So that's simple, okay? Part B, okay, expected return of A is just going to be 0.5 times 2% plus 32%, which gives us 17, right? 0.5 times 0.02 plus 0.32, okay? And for the defensive stock, it's going to be 0.5 times 3.5% plus 14%. Okay, so it equals 0.5 times 0.035 plus 0.14. And let me just make that to that. Okay. Okay, what I want to say over here is that with this table, okay, we should have, it's just easier if we actually put it into this format. And this is going to be scenario 1 and scenario 2. So I'd say this is boom. This is kind of like business as usual. Okay. So when you ask that question, what's the expected return on the market if it's really like to be 5% and 20%? What we did was here, we had actually the fact that it's 50% chance that that would just be in this scenario, 50% would be that. So that's what we get these two answers over here for the interest rates. Okay, so let's look at C. If the T-bill is 8%, the market returns equal to be 5 or 20%. Draw the SML for this economy. Okay, so all they're just saying over here is that we fundamentally are actually having, let me take that. Because it's more effort for me to actually graph it out, I'm just going to take that diagram. Okay, so the expected T-bill, the risk-free rate is 8%. That's why the line starts from here. Okay, and this is where the beta equals 0. So we start off with the y-axis is expected return, and the x-axis is the beta. Okay, so the T-bill risk-free rate when beta equals 0, so that's why it's right here, right? So if the beta for the month 1 point, expected rate of return for the market will be 0.5 times 20 plus 5% equals to 12.5, right? And that makes sense because we talked about the fact that if the T-bill rate is 8%, market is equally likely to be 5 on 20, that means it's going to be a 50% chance of either of these situations from hedging, so it's 12.5. So we say the expected return is 12.5%. At 1.0, it's 12.5%. Okay, so therefore we can draw a line from here to the market return. Right, so that's how we actually graph the security market line. Okay, so the equation of security market line is the risk-free rate's 8% given by this, plus beta times 12.5, because 12.5 is the market return, minus the risk-free rate of 8%. So that's the equation for security market line. So that's pretty straightforward stuff. Okay, so let's look at part E. What hurdle rate should be used by management for aggressive firm for a project with risk characteristics of the defensive firm stock? All right, so basically for part E, what we actually have over here, okay, is the hurdle rate is going to be determined by project beta, which is 70%, not by the firm's beta. Okay, so ultimately what happens is that the correct discount, okay, wait, sorry, my mistake. I just realized that for D, we have to plot the two securities such as SML graph and then work out what the alphas are of each one. Okay, so basically for part D, this is the chart, right? So what we need to do, we need to actually find out what the expected return is of RA, and that will be 8% plus 2.0 times 12.5 minus 8%. Okay, so we have the risk-free rate plus the beta times the market risk premium, which often expected return in the market, minus 8%. Okay, so remember, this is the formula that we have that, okay, right? So basically, this would be 0.08 plus 0.7 times 0.125 minus 0.08. That gives us 11.15%. Okay, so this is a rehash really of the CAPM. But what you're really learning over here is how to use the CAPM to answer different types of questions. And you can see how useful the formula actually is. Okay, so basically what happens is that the security analyst estimate for the return on D is only 8.75%. Okay, but what happens is that to calculate the alpha, okay, this is the actual expected return minus required return predicted by CAPM. Okay, so this actually means, all right, that you have equals to 8.75% minus 11.15%. And what's the answer for that? It's equals to 8.75 minus 11.5. So that's negative 2.75%. Okay? Yep, negative 2.75%. So this one we need to, okay, so that's actually what we have over here. Okay, and let me, all right, so that makes it more accurate. Okay, so the alpha is really the actual expected return minus the required return by CAPM. Now we know that the CAPM expected 11.15, but the actual return is 8.75, right? So basically, from here, okay, that is what the alpha is going to be. Okay, so now let's look at part E. Okay, now when we look at part E, it talks about what's the hurdle rate used by the management aggressive firm for a project with the risk characteristics of a defensive firm stock. Okay, so we talk about the hurdle rate. What they're really talking about is almost like a project rate, right? So we define by the project's beta, not by the firm's beta. Okay, I think we talked about in the lecture whereby when we talk about the beta of a firm, it's the beta of that firm for the financial security market, but not the risk of a project. Okay, so we should really be using a discount rate of 11.5%. Okay, we shouldn't really be using, right, the defensive firm's stock. We should be using the discount rate of 11.15. Okay, because that will be the appropriate discount rate of the firm. Okay, because it should be based on the project's beta, not the firm's beta. Okay, and we can see over here, okay, that the firm's beta was 0.7. So this, sorry, this is, So what I actually want to probably quickly do here is actually look at, this was actually supposed to be return of D, and this is going to be 0.7, which makes sense because that corresponds to this issue over here, and the E of RA equals to 8% plus 2.0 times 12.5 minus 8%. And this one would have been equals to 0.08 plus 2 times 0.125 minus 0.08, and that gives 17%. So therefore, the hurdle rate that the company should be using should be the defensive stocks, like a rate of return of 11.15.